I would like to explain more about this conservation of energy. I mentioned about first law of thermodynamics. There are another law for thermodynamics for those who don't know, right? Let's say we have two body at hot temperature, and then we have another body at colder temperatures. Let's say we have a colder temperature there, T cold. So we have the red color body, hot temperature, blue color body at colder temperature, and then we put them together. T hot, and after a period of time, it will reach to thermodynamic equilibrium. I just remove this part. I'm going to use it again afterwards. So we're going to have a smaller size TH, but a larger size of T. So they are both having the same equilibrium temperatures, right? So let's say this one is volume size and this one is smaller size. This one is smaller size, this one is bigger size. Now the whole process here tells you about zero law of thermodynamics. Zero law of thermodynamics, right? So it says that when there are two bodies at different temperature that mesh together, finally they will reach to the thermodynamic equilibrium. So that is the zero law of thermodynamics. Okay, and this one take time, right? It's not immediately happen, so it takes time. There is a response for it. And how it can be done, right? It can be done because there is a heat transfer from high temperature body to the low temperature body. So there is be a flow of heat. So we have a Q that flowing there. So we have high temperature, the heat is flowing from high temperature reservoir to low temperature reservoir, and at this rate, at this position, we have a second law of thermodynamics. Right, so we have a second law of thermodynamics. So second law of thermodynamics, there is two. One is a Kelvin Planck, right? Kelvin Planck statement, right? So high temperature reservoir to low temperature reservoir. And then for this body, right? So we have delta ES is sama juga dengan heat addition plus flow work plus boundary work. So what we have here, expansion of the body, this is the final size. So we have a boundary work. And for this case, you have same equation, delta ES. You have minus Q in, Q out, plus work boundary, right? Minus work boundary. Sorry, plus. Yes. So in this case, the body is doing work to its surrounding. Let's say this body is inside air. So it will work on air so that it can expand. Here, the temperature is become lower. The air doing work to the body so that it becomes smaller. And in this case, we have this first law of thermodynamics. Okay, so this is what I mean just now, the impact of this conservation of energy principles, and from that we derive another two law of thermodynamics.